Well, thanks for that great introduction. I'm Martijn Walraven. I work for a company called Meteor, based in San Francisco, although I work remotely from Amsterdam. And I work on what we call Apollo. It's a set of tools and services around GraphQL. And I work on the open source side of things. So I work on the mobile clients in particular. So before I start, how many of you have actually heard of GraphQL? And how many of you think they really know what GraphQL is? So that's a huge difference. And that is actually what I sort of expected. It's a technology that has gotten sort of well known in certain circles, especially the React community. But for mobile developers, it's still relatively unknown. So, slightly different question. How many of you have used the Facebook app over the last 5 years? So I think that's sort of almost everyone, which means that almost all of you have actually used GraphQL in the course of those 5 years. And some of you may even remember this version of the Facebook app. This was the first sort of modern native version of the main Facebook iOS app. And the version right before this was an HTML5 app. And it was, I mean, it didn't perform well. It was fairly buggy. So the team at Facebook decided to do a complete rewrite in sort of modern native iOS. But there was one big benefit to sort of building that app on HTML5 that they didn't want to lose, and that was their development velocity. Because the way they used HTML5 actually meant that they got to share a lot of code between the web platform and their mobile apps. It was all server rendered, nothing like sort of the modern web frameworks that people use that connect to APIs. And the big benefit of that, of course, is that you don't have to design an API layer. You don't have to sort of organize endpoints, talk to a backend team to get the data you want in a new version of your app. You also it makes it much easier to experiment with new features, to add new features. So the question that the team at Facebook responsible for this new version of the app asked themselves was basically, what would an ideal API for mobile apps look like? And the outcome of that was GraphQL. So GraphQL was developed as part of the redesign of the Facebook iOS app. And this may seem like sort of weird question. Of course, we think about our APIs, but we take a lot for granted. The expectation for most of us is that what we're actually designing is a sort of RESTful API, whatever that means in detail. So we expect an API to look like sort of list of endpoints. We describe what responses we expect. We describe sort of the query parameters that these different endpoints take. And that is how we think about APIs. We're also, especially as mobile developers, we're really familiar with the downsides of this way of thinking about APIs. So let's say this is the GitHub API, sort of fairly well-designed RESTful API, well-regarded. Let's say you're building an app, and you want to show a list of repositories. There's an endpoint for that. So you send a request, you get a response, you get the data you need, but you also get a lot of data you don't need. And this movie actually lasts a full minute. And this is just the repositories in our Apollo GraphQL organization. So if you imagine sort of only wanting to show a list of repositories, and you only need sort of the name of the repository, that's a lot of data you're sending over the network that you don't need. There's a lot of parsing you need to do that you wouldn't really want to do. And what's even worse is that that may not be all the data you need. So let's say you also want to show the list of sort of top 3 contributors for every repository. You need to call into a separate endpoint. and you need to call into that endpoint for every repository in that list. So now you're making a lot of extra round trips. And every round trip, of course, is a separate request. There's latency involved in sort of first getting the list and then calling that endpoint for every repository. There may be limits to the number of sort of requests you can send concurrently. So you quickly get into a situation where the performance is just unbearable. And we've all been there, and we've found ways to deal with it. So there are obviously ways to sort of solve these issues within a RESTful API, but they all come at a significant cost. And I think the main issue here, sort of fundamental tension between efficiently satisfying, on the one hand, the needs of your clients, like your different versions of your mobile app on different platforms, the specific screens that need a specific subset of the data on your server, and on the other hand, keeping the number of endpoints on your server manageable. And this tension also tends to manifest itself sort of between teams. So if you have a front-end team or like a mobile team and a back-end team, you get into these like long discussions. Like you, as a mobile developer, what you want is the exact data you need. But your back-end developer isn't likely to create a separate endpoint for every screen in every version of your app. So there's always compromise. And that often means that you're less efficient than you could be, and it also means that you might actually be blocked on back-end developers to implement new endpoints. So the answer the Facebook team that is responsible for sort of developing GraphQL came up with is to ask themselves this sort of fairly basic question: why would we actually let the server decide what data to return? Our app knows what data it needs. Why would we put the burden of defining all those separate endpoints on the server? And I think GraphQL is a sort of beautiful answer to this question, a beautiful solution to these issues, because it doesn't just let clients specify their own data needs. I mean, there are ad hoc solutions for this. Like you can add query parameters, like an include or an expand on specific endpoints. But what GraphQL is a really nice contract between your client and your server. So clients specify their data needs, but the server exposes its capabilities. The server, in a very structured way, can tell developers what data is actually available. And GraphQL, in its basic form, is really simple. So what you get out of a GraphQL request is a JSON response, just as you would for any RESTful API. But instead of calling a specific endpoint for the set of data you need, there's only one endpoint. And you send a GraphQL document to that endpoint. Basically, a bit of text in the GraphQL query language. And the shape of that query is very similar to the shape of the response. So it's very easy to get started. You see here we're asking for the titles for the posts in a certain API, let's say blog posts. But maybe in the next version of our API, we don't just want to show the title, but we also want to show the first name of the author. We don't have to change anything on the server, but the new version of our API just adds the first name of the author to the query. And that means the old version doesn't get data it doesn't need. The new version gets the exact data it needs. If the version after this decides it doesn't actually need the first name, we're not sending unnecessary data to newer versions. So it's a very sort of structured and convenient way of getting the exact data you need. And the way the server exposes its capabilities is through a schema. So the schema is basically a set of types with relationships between them. So in this case, we have the post type that exposes a title, a string. We could also ask for the number of votes. That's an integer. And we can, of course, ask for the author, which is a type in itself. And an author exposes first name, last name, and also the list of posts. So the schema is a contract between the client and server, and it's strongly typed, so you know what data to expect. And it's also self-documenting. So GraphQL actually includes an introspection mechanism, and I'll show you a really nice use case of that in a minute. Because GraphQL is not just about performance. Like the downsides of RESTful APIs that I showed you, overfetching, extra round trips, they're important. But I think the main benefit of GraphQL is that it's really designed for developers, for sort of mobile developers, front-end developers, product developers. It has been designed not with sort of the server developer in mind, but with the actual developer of the app that uses the API. And the best way of showing that is a tool that has been originally developed inside Facebook. It's an open source tool. It's called GraphQL, and it's basically a query editor. So this uses the introspection mechanism of the GraphQL server, and it gives you a really nice way of interactively composing queries. So I can add the number of votes here, the author, last name, and as you can see, it allows you to sort of build up your queries piece by piece, get immediate results. Something I should also mention is that GraphQL is not just a query language. It doesn't just allow you to read data, but you can also use it to mutate data. And the mechanism for that is very similar. So we have an upvote post. Mutation defined in the schema. And the way mutations work is they're basically functions with side effects, or queries with side effects. So they, as a side effect, this mutation upvotes a certain post, but it also allows you to get back data. And in most cases, what you want to do is get back the data that changed. So you can imagine sort of state mutations in a complicated schema can actually make many changes. And you don't need all the changes. You just need the data that your app actually shows. So in this case, we want the updated number of votes. And every time we execute the mutation, the number of votes increments. So I want to show you some slightly more advanced features of GraphQL, switching to a different schema. This is a sort of well-known schema in the GraphQL community. It's a Star Wars API. And one of the nice features about GraphQL introspection is that it also allows you to sort of document your APIs as part of the schema itself. So GraphQL includes basically an API documentation browser. And you can easily see sort of what fields are available. So here, we can get the hero of a certain episode. These are the episodes that are defined in this API. What you get back is a character. Character is what's known as an interface. And we have two implementations in this API, human and droid. So human and droid have all these fields in common. But droids, for instance, also have a primary function. So if we query this API, so we want the hero of episode Jedi. Let's see who that is. It's R2-D2. But for Empire, it's Luke Skywalker. Then, well, let me show the other one first. The number of, so these are the episodes that the character appears in. These are enumerations, so there's an enumeration type in GraphQL. That's why, for instance, code completion here works. So it can actually show you what different episodes have been defined. We can ask for the friends. And as you may remember, these are all of type character, an interface. But the concrete implementations of that are either human or droid. So we can ask for the type name. That tells us if it's a human or a droid. But something else we can do is we can actually add sort of conditional fragments. So we can say, if this is a droid, we also want the primary function. So here for C3PO and R2D2, we get the primary function. We don't get that for Han Solo and Leia. The last thing I want to show here is you can imagine sort of queries specify nested data needs, and in many cases, parts of this are reusable. So they're reusable over sort of multiple queries. When you bind the results of these queries to your UI, you may also have UI components that are shared between screens. So the mechanism here is the use of a fragment. So for instance, we can define a hero details fragment. Oh. We have to define what type. And then, for instance, we could switch out this part. You can see that there are sort of integrated errors. In this case, it tells us that the fragment isn't used because we have to expand the fragment in place. You can see the result doesn't actually change, but as you will see, the use of fragments also has implications for the Swift API that we generate from this. All right. So there's a lot more to say about GraphQL. GraphQL.org is a nice resource for this. It even has sort of every code sample here is a graphical instance, so it's interactive. And going back to the Facebook iOS app, this was 2012. It has been used inside Facebook for over 5 years. It actually serves like over 300 billion requests per day. Like all the data from the mobile apps and parts of the web app go through GraphQL. It was open sourced in 2015, and it's really taken off. Like there are many companies that have adopted GraphQL. These are some of the people that attended the sort of first GraphQL conference that we organized last year. There are actually many more now. And we've even seen the first examples of public APIs. So GitHub exposes a GraphQL API now, and there are other companies that have followed that example. So to summarize, why would you want to use GraphQL? It really sort of empowers and unblocks you as an app developer. You no longer have to wait for your backend team. And the backend team can focus on exposing those capabilities, and it doesn't have to write endpoints for individual clients. Another important part of that is that a schema can evolve. There is usually no need for separate API versions. The idea is that your schema changes should be backwards compatible. And that is something that Facebook does. They claim even their sort of original app from 2012 still runs against the same endpoint, against the modern endpoint. They never actually make any changes that break any of the clients that are still out there in the wild. And they have an integrated mechanism in their CI process. So if you make a change to a schema that's backwards incompatible, you actually get a response from a bot. So I think how am I doing on time? So before I start talking about the client, a few words about the server, because you might wonder, well, GraphQL is nice, but I don't have a GraphQL API. So what's important to realize is that GraphQL is not sort of a query language like SQL. It's not bound to a specific backend technology like a database. It's a really lightweight way of specifying what data is available to clients. And the way that works is every field in your schema is actually a function. So it can take arguments. And the way you implement a GraphQL server is by specifying these resolver functions. So every field on your schema can have a function that can sort of perform arbitrary processing to give you the data you need. And this is a very simple in-memory model. It's like a Node.js JavaScript implementation. And basically, for instance, to get the posts for an author, the GraphQL server, if it reaches that field in a query, will call this function and basically ask for those posts. And then you can do whatever you want. So this was a very simple in-memory example. You can call into a database. You can call into an existing RESTful API. You can call into like other systems like Salesforce, and you can also combine these. So you can have a schema that actually connects, for instance, a large set of microservices that would otherwise have to be treated separately. There are implementations for many different languages: Python, Scala, Java, Go, and that brings us to the client. So in order to get a GraphQL response, all you actually need to do is perform an HTTP request. We all know how to do that. You can use like something simple like an SURL session. You can use a library like AlamoFire. And what you do is you send a request with the query in the in the post body. That's usually how you do it. And then you get back your data. So this works fine, and for simple sort of parts of your app or tooling, this might be a fine way of doing this. But we've been working on a GraphQL client for iOS. So it's written in Swift, and we've described it as a strongly typed caching GraphQL client. So what does that mean? Well, strongly typed is an important aspect of it. We all know sort of what a mess it is to deal with JSON responses. You wouldn't want to write code like this manually. So of course, what most of us do is we sort of use some kind of mapping layer or mapping tool to get a nice structured response, a typed response. And that works. It's a lot of work, either writing it by hand or writing the definitions that will lead to these types being generated. And it doesn't really make sense because in GraphQL we already have all those definitions as part of the schema. So we could just generate those response types from the schema. And that would work. It would already be an improvement. But it wouldn't really give us all the benefits of GraphQL. Because, for instance, in this case, we only ask for the title of the post. But because the generated type depends on the schema, on sort of all the data that's available, all of the data is optional. So we still have to perform sort of manual checks. And a much nicer way is to use query models. So the way this works is we generate models that depend on the exact query. There's no sort of overall post type, global post type, or a global author type. There's just the post from this query and the author that's nested in that part of the response. So that gives you sort of static type safety from your server to your UI. And the best way to show that is through a code example. So this is, oh wait, let me show you the app first. This is a very simple app. It's based on the sort of blog API that I showed before. And as you can see here, this is Xcode with a GraphQL plugin that I wrote that gives you sort of syntax highlighting for GraphQL. And it also allows you to use the companion view for that. And the nice thing about this is, for instance, here we're performing an all posts query. We're getting the result. We're putting it in the posts property. The posts property here you see is of type all posts query data post. So it's specific to that query. And then, I mean, you can actually see here that, of course, that's. And what we do here is we actually configure the table view cell with a fragment. So that's a really nice way of using fragments. Here, the query, the all post query, doesn't actually specify what data it needs. It uses the post details fragment, and it's up to, in this case, the table view cell to define that fragment, which means that the table view cell is reusable. We can reuse it in multiple queries. So if I switch here to the post table view cell, you can see the companion view switches with it. That's really nice. And this, of course, is all typed. So for instance, you can see here what data is actually available. If we make changes to the GraphQL and rebuild, we regenerate the code. So that gives us a compile time error if we try to access data that is not actually fetched. So it's a really nice safety mechanism. There's also an integrated validation step for GraphQL queries. So for instance, authors don't have an email. If we try to add it to the query, we get a validation error in line here. And lastly, there's the update vote mutation. We here perform that mutation when the upvote button is clicked. And notice we don't actually do any work here to update the UI. And that's an important property of sort of the architecture that this allows. I'll say more about this in a moment. But all the sort of updating is one way. So it's actually the so when we upvote a particular post here, what happens is the query watcher here gets notified that data has changed, and then the table view cell gets a chance to update. So the generated models are value types. They're structs, which means they're thread safe, at least depending on how you use them, but they're more thread safe than classes would be. It's compared to something like core data. It actually means that you're not sort of runtime navigating the results. You can be sure that the data you request is actually there once you get the struct. So there's no sort of surprises, no faults that get fired and that sort of mess up your app's performance. And another important aspect is caching. So the way you would do caching with a RESTful API is either on the sort of individual request level, like request level caching, or add something on top of it, for instance, caching in core data manually. And the sort of downside of request level caching is that, for instance, in a master detail view, if the data for these two screens comes from different queries, like if you go to the detail screen and you upvote the post, you go back to the master list, you expect that vote count to sort of reflect the change you just made. If that doesn't happen, it's a UI bug. You can either sort of manually update the UI, but that quickly gets really complicated, really messed up. Or, like I said, you can add something like core data on top of it. What Apollo iOS gives you is sort of caching by default, and this is known as normalized caching. So what normalized caching does is it breaks up your results into individual objects, and then uses the normalized cache to automatically keep query results consistent. So if, for instance, a detail query returns a different vote count, that vote count is seen as part of a post that is also part of the all post query. And if a part of your UI is watching that query, it will automatically get the updated data. And we can even sort of load queries from the cache completely if all the data is there. So this, for instance, could be the response from your server, just a like JSON response. you can see that the friends here are nested inside the data. All normalization means is that we change this to a flat, like a record-like representation. So instead of friends being nested, we now have top-level objects for individual friends, which means that if the name of a friend changes or some other property, it won't just be reflected in sort of that friends connection, but anytime, for instance, Luke Skywalker is referenced in your app. So all data updates go through the store. It gives you sort of nice one-way data flow. And this is true of mutation results, things like optimistic updates, like making a change to your store while waiting for a response from the server, can really speed up your UI. And there's also the idea of real-time updates, so using a WebSocket connection, and in addition to the GraphQL spec called subscriptions, to get updated information from your server as it happens. So the store abstraction is part of the sort of the part of Apollo iOS that is responsible for sort of giving you this nice view on the sort of single source of truth of your data. But underlying that is a normalized cache. The standard implementation is in memory. We have a very basic implementation of a SQLite store now. We're working with sort of different contributors, and this is a team from Airbnb that's helping us with the SQLite store. And one of the most recent additions is the ability to sort of manually access the store, make changes to the store, but in a typed manner. So for instance, here we can actually add a friend to the list. It's completely, again, type safe. And I think it's a really elegant way of making data changes. We also have an Apollo Android version for those of you who work on multiple platforms or have other teams working on Android. This project is, again, made possible with help from many contributors, but the important ones are Airbnb and people from Shopify and New York Times. We're also working on integrating the JavaScript client and the native clients. So that means giving you a consistent experience across these different platforms, but we're even working on a way to share the store between React Native and the native parts of your app. So we've seen examples of organizations that adopt React Native for parts of their app, and you would still like to get that data consistency and avoid sort of fetching duplicate data. So if you're interested in GraphQL, definitely check out graphql.org. That's the best way of sort of reading about the language, experimenting with the query syntax. We have a Medium blog on dev-blog.apollodata.com. So we publish regularly on sort of different aspects of GraphQL and the clients. And we're also hiring. So if you're interested in working on GraphQL in some capacity, please get back to me. And yeah, I'm hoping for some fruitful discussions, either as part of the Q&A or please come up after me and ask me about GraphQL.